All right, so I know I promised the next thing we would talk about would be CIDR, but before there was CIDR, we had classful IP addresses, and we really need to talk about those before we go any further. So I suggest we get right to it. At the very beginning, when we just started allocating IP addresses to computers, things were a bit different. Everyone thought that we would always be able to separate three sizes of networks: large networks, medium networks, and small networks. And the idea behind classes was that once a company or a university would want to get an address range, they would be given a range depending on the size of their network. So Class A networks were only supposed to be given to very large networks. And that is because in a Class A network, the first 8 bits or the first octet is the only octet that represents the network portion of that address. That means that there is only 256 Class A networks. One Class A network has 2 to the power of 24 different host addresses or different combinations for the host portion of the address. 2 to the power of 24 is somewhere around 16 million addresses. Now, hopefully you'll agree with me that there's probably not many networks in the world that actually need that many public addresses. The next class is Class B, which is somewhere between Class A and Class C. Class B networks have 2 octets representing the network portion of the address. The other 2 octets represent the host portion of the address. These were meant to be given to medium networks, and then Class C networks were meant to be allocated to very small networks. A Class C network is kind of opposite from the Class A network because Class C networks have its first 3 octets representing the network portion and only 1 octet representing the host portion. So one Class C network can only have 256 different IP addresses in one subnet. Now, one more thing, there are actually additional 2 subnets, classes D and E. D is reserved for multicasting and E is experimental and is used for research and documentation. Now let's look at some examples. Here's a Class A network 71.3.99.2. This is the network portion. So 71, the first octet, is the only octet that represents the network portion. The other 3 octets represent the host portion. Now, how do we determine the network address? So we take the network portion, we copy that, and then in the host portion, we put zeros. So 71,000 is going to be our network address for this example. Now, how do we determine the broadcast address? It's similar. So we also need to copy the network portion, which is 71, and then in the host portion, we're going to put all ones. Of course, this is in binary format. So when you convert 8 ones to a decimal format, you're going to get 255. So we're going to have 71.255.255.255. Now, how do we actually know to which class does a certain IP address or an IP range belong to? We determine that by looking at the first octet. So Class A addresses are somewhere in between 1.0.0.0 and 126.255.255.255. So if we have the first octet ranging from 1 to 126, we have ourselves a Class A IP address. Let's look at another example, this time from class B. 155.8.101.33. So in a class B network, the first two octets represent the network portion, and then the last two octets represent the host portion. So what is the network address in this example? Again, we're going to copy the network portion, which is 155.8. And then in the host portion, we're going to use all zeros. Of course, all zeros in binary format are the same in decimal format. So the network address is going to be 155.8.0.0. Now the broadcast address is going to be 155.8. That's the network portion. And in the host portion, we're going to use all ones. And just as in the previous example, 8 ones in binary format equals to 255 in decimal format. And how do we know that an IP address belongs to class B? So again, we look at only the first octet. And if the first octet is somewhere between 128 and 191, that is class B address. Let's see our third example, this time from class C. So here we have 201.65.4.137. Here, the first three octets represent the network portion, and only the last octet represents the host portion. As in the previous examples, we're going to determine the network address, and we'll get the network address by copying the network portion, 201.65.4, and then in the host portion, we're going to put 0. So that is our network address for this example. Let's determine the broadcast address. To determine the broadcast address, we're going to copy the network portion, and in the host portion, we're going to put all ones. Again, we're going to have 255 for each segment or each octet that represents the host portion, and since we only have one, it's going to be 255 at the end, and that's our broadcast address. Now, how do we know that an address belongs to class C? So once more, we look at the first octet, and if it's somewhere between 192 and 223, that's a class C address. Everything above 224 or everything above all IP addresses that start with 254 and upwards are going to belong to those two additional classes, class D and class E. Finally, as I promised some slides ago, here's the table that summarizes all 5 classes. As we've already learned in the examples, we recognize all 5 classes only by looking at the first octet. So here's the first octet, here's the second octet, here's the third octet, and here's the fourth octet. Class A addresses, or rather the first octet of Class A addresses, ranges from 1 to 126. Then we skip 127, which is reserved for loopback, and Class B starts at 128 and ends at 191. Class C begins at 192 and ends at 223. And let me clarify one more thing. So regardless of what the first octet is, each of these classes can have absolutely anything in the other octet. So it's only important to know what we have in the first octet. That is how we determine the class. All the other octets are just combinations of network portion and host portion of the IP address. All right, now that we're done with the table, let's go through some additional examples. So 200.200.200.200. Question for you is, which class does this IP address belong to? as we discussed, we only look at the first octet. So the first octet is 200. That, looking at this table again, would be class C. All right, let's go to the next example. 1.1.1.1. This is definitely class A. Next example is 192.168.1.1. This is probably the most familiar IP address, and it belongs in class C. Fourth example, 44.13.0.0. So this is also class A because the first octet is between 1 and 126. Fifth example, 100.0.0.255. This is also class A. And the last example would be 155.255.255.7. So the first octet is 155. Class A is between 1 and 126. Class B is between 128 and 191. So this IP belongs to class B. And that would be all for this lesson. See you in the next one, where we definitely talk about